I'm William Smart. I'm the Creative Director of Smart Design Studio. Yeah, the project's probably, it's a 3-year project for us, so it went over many years and took about a year and a bit actually to design and document and work out how. I think there were moments on the way where I thought, oh, it's quite a lot of work. I don't know whether I've bitten off a bit more than I can chew. But we were collaborating with engineers we'd worked with before. I'd been working with a great builder. They had amazing tradesmen. It was certainly a united front, and we all worked on it together. And we had a philosophy of bringing everyone to the table. So we would have meetings with concreters, with bricklayers, with engineers, with experts from UTS, all at the table to talk about how we would do this. And my role there is to establish what the goal is and to share an idea about it, and then to open up the floor for discussion, and people engage, they made it their own. These are structural brick vaults, and that means that we don't have any steel that holds up the roof. And the shape is called a catenary shape, and it's the same shape as holding a string. So if you were to hold a string, it will form an arc, and the arc is called a catenary. If you flip it up the other way, so it goes upwards, the pressure that pushes out equalizes with the pressure that pushes down. So gravity is balanced in perfect harmony. And that means that the load of the brick is evenly distributed down to the ground. The importance of that is when you try to put glass into a room like this, and you can probably see that behind, we can't afford for the shape of the arc to grow outwards or inwards in any way, because it will put pressure on the glass and make that crack. So for us, there was a marriage there between experts from UTS and engineers that I've been working with for many years in coming together and talking about how we would achieve this and what would happen when we built it. So we built a prototype in the old warehouse to be sure that it would work, and also to test the strength of the vault. So what you have here is a structural brick vault. So it has bricks, regular bricks laid in an arch form, and then across that is a very thin layer of concrete. It's only 60 mils thick. We built that to be sure that the false work that we'd worked out could be erected, the bricks could go on, we could remove the false work afterwards, it would stand up, and then after that we destroyed it. We brought in a saw and cut out pieces and took it to a lab at UTS and tested the strength of the materials, and we also demolished it by testing it. So by putting pressure on in certain areas and finding out whether it would collapse or not. So we wanted to be sure that it was strong, but also to be sure that it would give us the desired effect. There's numerous engineering feats on the project. One of them is to build the facade of the building, and you'll notice there that there's a portion where the brickwork leans out at 40 degrees to the horizontal. So it's real bricks laid with real mortar, tied back to a steel frame with brick ties, leaning out at an angle. And there was a part there where I just wondered how the bricklayers would do it, and they told me they'd worked out a way, and it was an ingenious way of building that. That's something I didn't know how, but I was quite confident we'd be able to work it out. In addition to that, building the brick vaults was challenging. We weren't sure how it would work, whether it would expose things we hadn't thought about. There was a lot of challenges in trying to get these large sheets of glass into place. So there was pressure to put a joint down the centre of it, which together with the builders we overcame, and they're 6.5 metre sheets of glass. We also have a studio with no air conditioning, but it has underfloor cooling, and that's a challenge in Sydney where the humidity is high, because it can cause condensation on the floor. And with 40 people working in a studio and computers running, it can get warm. So we had to manage all that. And we have 260 solar panels on our roof, so we're able to make enough energy to run this building and our 2 neighbours, and we're also able to avoid putting a substation into the site. And substations for me was a real loss. It's an ugly thing. It produces electromagnetic energy that I didn't want to be around, and it's expensive. It's just a whole lot of losses that we met and negotiated with Ausgrid to overcome by putting an alternative solution in. We chose brick on this project because we wanted to be in context with this old heritage area where you see brick warehouses. So the fundamental idea was that we wanted to extend and build upon that heritage that exists here at the moment. And then with brick, we chose to use it because we could make it do things you don't see it do. So we could build vaults, we could do curved facades. It's a small module that can be put together in beautiful ways. In addition to that, I wanted to try things like having a place with no mortar joints internally to see if I can make that material even more kind of refined and beautiful. There is also something that I love about brick, and it's its imperfection. I love these kind of precise shapes, like a perfectly shaped catenary vault, combined together with a raw material that is chipped and rough and bent and irregular and chalky and a little bit imperfect. I think that combination of roughness with precision is beautiful. My favourite part is definitely our home. I love walking up the stairs and looking through the space at the end of the day. And just recently, I suppose due to the working from home scenario, we've been spending quite a bit of time here, and it's just beautiful to be in. The light tracks through the space in a beautiful way. It's very quiet. There's a kind of I find a joy to the shape of the room, and I think we've nailed so many aspects of it that I kind of sit here and feel like I'm in a very well-tailored space.